So we are starting with the concept of norms. So norms मतलब क्या? Norms is basically a function that will give you length or size of any vector, obviously not zero vectors. So machine learning में बहुत बार हमें measure करना होता है size of vectors. So we do it using norms. Okay. There are different types of norms. We are going to see some. So many a times norms are clubbed under P norms family, where P is any number which is greater than or equal to 1. Okay, so P norms का formula कैसे लिखा जाता है? It is written like this. This two lines and P you see, मतलब it is a denotion of norm. So it is x1 raised to P plus x2 raised to P goes on till xn raised to P. The entire thing is taken to the power of 1 upon P. Okay. So every element of vector x has the power p. Then you take their sum, which is raised to the power 1 upon p. Okay, ये अगर in short represent करना है, so this you can replace by the summation. So first you take the summation from I is equal to 1 to n, x of I raised to p, and the entire thing, the entire sum you take to the power of 1 upon p. Now, the norm function should satisfy following condition. This comes in exam many a time, so please do it nicely. If a norm of x is greater than 0, then x is not equal to 0. If norm of x is greater than 0, then x is not equal to 0. मतलब वो 0 वेक्टर नहीं हो सकता. अगर किसी भी वेक्टर का नॉर्म 0 से बड़ा है तो वो वेक्टर 0 वेक्टर नहीं हो सकता. And if norm is equal to 0, then x has to be a 0 vector. Norm अगर 0 है तो x has to be a 0 vector. Same thing is written as equations over here. If f of x, we are assuming f to be our norm function. So f of x is greater than 0, then x cannot be equal to 0. If f of x is equal to 0, then x is equal to 0. Suppose I have a scalar k, then f of kx should be equal to k into f of x. And we have other vector y. You have one vector x and there is another vector y. Then the norm of x plus y should always be less than or equal to this addition of norms taken separately, that is f of x plus f of y. So you take the norm of x separately, you take the norm of y separately, you add it. This, whatever this number is there, this should be greater than or equal to f of x plus y. Okay, so if you talk reversely, it will mean the norm of x and y together has to be less than or equal to addition of this norms taken separately. So if any function that satisfies the above three properties can be called as a norm. सबसे पहला basic norm is Manhattan distance, or one norm what we call as, okay, it measures the distance between 2 points as you travel along the orthogonal block. So let us see an example. Basically, how is this calculated? It is simply calculated as the addition of the absolute values. It is calculated as the addition of the absolute values. Okay. Now you have something which is called as infinity norm. Infinity norm is also called as max norm. So what we do over here is we take the absolute values and we calculate the maximum out of it. So what are the absolute values over here? 2, 4 and 5. -5 का 5 लेंगे ना हम लोग अगर absolute लिया तो. So इसमें से सबसे बड़ा नंबर कौन सा है? 5. Okay. The next one is Euclidean norm, which is also called as 2 norm. So Euclidean norm basically कैसे calculate होता है? Suppose we are having a vector 2, 4, then we use the same formula over here which is given over here, and we just replace p by 2. Okay, so x1 raised to 2 plus x2 raised to 2, everything raised to 1 upon 2. Okay, so 2 square plus 4 square, it gives you 4 plus 16. So under root of 20 is your Euclidean norm. Now the question arises, where do we use these norms with reference to deep learning situation? So the first kind of application can be, I want to measure errors. So how far my values are from how far are my values from the actual values? So predicted versus actual. You can use it to prevent the overfitting. So regularization में use होता है. And you can also use it for controlling the magnitude of weights in the optimization thing. So that is where you use norms. So let us start with the next topic, that is called as Eigen decomposition. While reading it, please read it like this. So decomposition is one word and Eigen is another word. So what is this concept of Eigen decomposition? बहुत बार हमें क्या करना होता है ना कि हमारा जो मैट्रिक्स है उसको हमें किसी पार्ट्स में ब्रेक करना होता है. सो आइगन डीकम्पोजिशन में बेसिकली आपका जो मैट्रिक्स है वो आइगन वैल्यूज एंड आइगन वेक्टर्स में ब्रेक हो जाता है. अभी ब्रेक करने का मतलब क्या, जैसे हम लोग ने कोई नंबर लिया तो हम लोग उसके प्राइम फैक्टर्स कैलकुलेट करते हैं. सो अज्यूम करो कि हम लोग सेम चीज मैट्रिक्स के लिए भी कर रहे हैं. सो दैट इज द बेसिक कंसेप्ट ऑफ आइगन डीकम्पोजिशन. अभी ये क्यों करना है, वेयर आर वी गोइंग टू यूज इट और वाई आर वी डूइंग इट. सो डीकम्पोजिशन ही क्यों करना है? मुझे किसी चीज के प्रॉपर्टीज पता करने, पूरे मैट्रिक्स पे जितना कैलकुलेशन इजी होगा उससे ज्यादा शायद से कैलकुलेशन इजी होगा उसके कंपोनेंट्स पे, या फिर मुझे मशीन लर्निंग एल्गोरिथम में यूज करना है जैसे प्रिंसिपल कंपोनेंट एनालिसिस. सो बेसिकली हमारा एम ये होता है कि वी वांट टू रिड्यूस द डायमेंशनैलिटी ऑफ समथिंग. सो व्हेन यू वांट टू रिड्यूस द डायमेंशनैलिटी ऑफ समथिंग वी कैन यूज आइगन डीकम्पोजिशन. ओके, so let us go ahead with it. As I told you, if I want to break something into its simplified form so that I can understand the properties in a better manner, then I do it like this. मैंने prime factors का भी example आपको दिया है. Okay, so to make complex operations into a simple structure, matrix decompositions are quite useful. And matrix decomposition tools also will help you to reducing the matrix to its constituent parts. Okay. Now, Eigen decomposition of a matrix. Please again read it like this. Wherever this comes, you are going to read it like this. Eigen is one word and decomposition is a complete word together. So Eigen decomposition of a matrix is widely used matrix decomposition, which involves decomposition of a square matrix into the set of eigenvectors and eigenvalues. And this kind of decomposition will also help you in principal component analysis. Like I told you, we are covering principal component analysis in one of our chapters. Okay. So a vector is an eigenvector of a matrix if it fulfills the following equation, and the equation is like this: AV is equal to lambda. Now this equation is called as eigenvalue equation, जहाँ पे A is your square matrix that we are going to decompose. V is a non-zero eigenvector of the matrix, and lambda is nothing but the eigenvalue. Okay. Now we have left eigenvector and we have right eigenvector. Okay, so अगर मुझे left eigenvector लिखना है then I'll write like this. Okay, V transpose A is equal to lambda. Right eigenvector लिखना है तो we write it like this. So it is up to you whether you are using left eigenvector or right eigenvector. Okay. Now it is possible that the matrix can have one eigenvector and one eigenvalue for each aspect of a parent matrix. ये ज़रूरी नहीं है कि अगर स्क्वायर मैट्रिक्स है तो उसका डिकम्पोजिशन होगा ही. सम डिकम्पोजिशन कॉम्प्लेक्स नंबर्स में भी जाता है. सो you have to be careful when you are using Eigen decomposition. You have to first check whether the decomposition is possible or it is not possible. Okay, a parent matrix would be presented as a product of eigenvalues and eigenvectors. So if I want to write in terms of the parent matrix, that is A, so I can write it like this: A is equal to V into DIAG. DIAG is nothing but diagonal of lambda, that is diagonal of your angle eigenvalue. So what you do is you write all your eigenvalues as a diagonal, and v raised to minus 1 is nothing but it is v inverse. So it is inverse of your eigenvectors. Okay. This statement typically tells you how to pronounce eigen. Now, decomposition does not mean compression of the matrix. It means breaking it down into the constituent parts to make certain operations easy to perform, as I told you earlier. So, eigen decomposition of matrix gives you useful facts about the matrix. If the eigenvalues are 0, then the matrix is said to be singular. Now, we come to eigenvalues and eigenvectors. So, eigenvectors are unit vectors that mean their length or magnitude is equal to 1, and they are often known as right vectors, which simply mean a column vector, or they can be called as a row vector or the left vector. So, right है तो column vector, row vector बोला तो left vector. What is right and left I've shown you above. Okay, if a matrix has only positive eigenvalues, then it is called as a positive definite matrix. If it has all negative values, then it is known as negative definite matrix. Mathematically, even though it is quite difficult to calculate eigenvalues and eigenvectors, it can be done obviously, but it is a bit tedious process. Writing a program to calculate eigenvalues and eigenvectors is quite easy. Uses define a matrix as we have defined over here, and then you use a function called as Eig. What you will get is you will get eigenvalues and eigenvectors for the particular matrix. That's it for this chapter. Thank you.